morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with Everest Networks. Today's host is Ryan McKenzie. He is their North American Director of Sales, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and Ryan will answer them at the end of today's presentation. Ryan, I'm finished for now. You can go ahead and take it on over.
Thank you, Julie, and thank you, everyone, for the time. Thank you for attending. We really appreciate the opportunity, and we value your time, so we want to make this short, sweet, and to the point, and hopefully it will be informative, and you'll be able to get something out of it. First of all, want to thank Microcom. Microcom is a fantastic partner of ours. We appreciate the help that they give us in getting our name out there, and we hope that, that those that are listening are deeply engaged with their Microcom rep, and we'll be able to follow up with them after if there's any additional questions or concerns about the Everest product. My name is Ryan McKenzie, as Julie mentioned, and I've been in the Wi-Fi industry for a number of years, about 18 years now, and have had multiple roles, anywhere from an engineer to a salesperson to installer to garbage man. And so I bring a lot of different variable experience to this webinar. And today what we'd like to talk about is an exciting new product, an exciting new development at Everest Networks, and that is the introduction of our AP300. The AP300 is our new low-cost tri-band AP, which will complement the previous quad-band access points that we've already released at Everest Networks. So if this is an introduction to you on Everest Networks, if this is the first time you've ever heard of Everest, I'd like to take a second and just give you a little bit of a background. Everest Networks is a world leader in multi-band APs. Multi-band APs, it's really kind of a new term that we're starting to see, where in the past we've always had either single band, meaning a 2.4 or a 5 gigahertz access point, or we've started to see dual band. In dual band, you'd have a 2.4 and a 5 gigahertz that would be broadcasting at the same time. There's a new trend that is most manufacturers are now following, called multiband. In multiband, we actually have 3, 4, or more radios inside of an access point. And Everest really is the world leader in that. We released a number of years ago our quad APs, which included 4+ concurrent radios per AP. We have software steerable antennas, advanced military spec hardware. I won't bore you with this. There's other presentations we've done which go into a lot more detail. But these products that we introduced in 2016 have really led the way in multi-band APs, and have been proven in the field over and over and over again in multiple sports arenas. In fact, I'm at a sports arena now doing an installation, and continues to be the world leader in defining how quad and multi-band APs are being built and deployed. So today, we're excited to introduce the AP300. The difference between this and some of the other access points that we've had in the past is that this is designed to be an affordable option. It is when you're going into an NFL stadium or to a large arena, you have the budget and the ability to pay a higher amount for a high quality product. For those of you that are deploying into a hotel or into an office, you don't have that kind of budget. And so we are trying to introduce the same type of technology in an affordable package. So the AP300 gives us exactly that. It is a tri-band access point that gives you an indoor AP with concurrent triple radio at 802.11 AC Wave 2. So that is the current latest technology. And that gives you an overall PHY rate or physical rate of over 2 gig per second. So we're very excited about this, and all this is in a package of under $400. Now, as we talk about prices today, I just want you to know we're talking about list price, and at the end we're going to talk about a little bit about special, and there is some special pricing that your Microcom rep will offer you. So I'd encourage you to reach out to the Microcom rep after this meeting and take advantage of that special price. So why do we care so much about multiband? Why are we talking about multiband, and why is the AP300 so exciting? Well, as we all know, if you've been in the Wi-Fi industry for a while, we know that Wi-Fi is just growing. No matter what they talk about on new technology, for example, 5G and others that are coming on the cellular side, there's still always a need for Wi-Fi. In fact, most studies put it that in 2021 and beyond, we're going to have multiple devices per user. Right now, the number is about 6 devices per user, depending on what part of the world you're in. And it's it's predicted to increase. North America is predicted to have up to 13 devices per user in the next few years. All of those devices will need to be connected and stay connected, no matter where they go. As a Wi-Fi designer, many of us have struggled with this trend of more devices in the same amount of space. 10 years ago, if you designed a Wi-Fi for a hotel, you might have 2 to 3 devices in a hotel room. Now that's not the case. You get a family of 4 in a hotel room, you might have up to 13 to 20 devices in that hotel room. As a wireless engineer, we use a lot of rule of thumbs. And one of the rule of thumbs is that you have up to 30 clients per access point or 30 clients per radio. There's a very good reason for that. We won't go into a lot of the science behind that right now, but it all comes down to airtime. And that airtime is really the amount of time that wireless device, that radio, needs to communicate to a client device. So your laptop, your cell phone, etc. And there's only so many ways that you can divide that second up. And so 30 is a good round number for a standard density environment. You started to see, as high density environments started to come into play, you started to see people push that. And that has led to a problem, which is, how do we account for all this density without and continue our installation model that we've had? So one of the things to consider is coverage versus capacity. In the last 5 to 7 years, as we talked about in a hotel environment, for example, on the left-hand side, this is how you design a Wi-Fi coverage area in a hotel 7, 10 years ago. You'd have maybe 5, 6 APs covering a large area, because all you really cared about is coverage. Now we're worried more about capacity, and in capacity, the problem is you have an access point that actually reaches too far now. When an access point reaches too far now, it causes interference. And so we need to accommodate for that somehow and add capacity without modifying our installation approach. We've seen this everywhere we go. If you're in the Wi-Fi industry, it is a high density world. And so you have more people in the same amount of space. You have people that are using Wi-Fi for guest and student access, point of sale, user and inventory tracking, digital signage, cellular offload, et cetera. And so there is a persistent need and continued need for Wi-Fi. And we as Wi-Fi engineers need to step up our game in order to meet the demand in the marketplace. So when we start talking about the difference between coverage and capacity, we have seen the standard mode of engineering now is to add more access points. As we saw in the previous example, in order to account for that capacity, if you can only do 30 to 50 clients per AP, then the answer is you have to increase the number of access points that you have in a deployment. That means that we're going from, like in this case, we are going from a hotel that might have 5 or 6 APs in the hallway to now having 1 AP per room, for example. Now, why do we care about that, and why are we so excited about the AP300? Well, let's look at some of the nitty-gritty and get under the hood and see what's going on. So on the left-hand side, you're going to see a standard dual-band access point. That dual-band access point has one 2.4 radio and one 5 gig radio. Those broadcast at the same time and can have up to 30 to 50 clients on each device. The Everest on the right, the quad, this is our quad AP that we have been so proud of. We have 3 5 gigahertz radios and one 2.4 gigahertz radio. This handles hundreds of clients at the same time and gives you the type of performance you would expect on a much smaller standard capacity network. And what we're introducing now is the tri-band AP, which is the AP300, and is what you see in the middle here. The AP300 has 2 independently controlled 5 gigahertz radios, 2 independent antennas for those 5 gigahertz radios, and then a completely separate 2.4 gigahertz radio and access point. Now, why do we want to take a minute to look at this? Well, as you are looking at the new technology that's coming out, multiband, tri-band, quad band, these are all terms that you're going to start seeing more and more of. And as you evaluate different vendors use that terminology a little bit differently. We haven't really standardized on it yet. And so when we talk about a multi-band or a tri-band AP like the AP300, we mean specifically that there are 3 radios in each access point that are broadcasting for clients. That means that each one of those radios can handle more clients than single radios. And we are not using those radios for things like scanning or IoT or other things. So we're actually using it for propagation. There are many manufacturers and vendors out there that do have tri-band access points and tri-band routers, for example, but in a lot of cases, one of those radios is not necessarily devoted to clients, it's devoted to scanning. Not a bad thing, just you need to be aware of that as you go in, that a tri-band router that has one radio devoted to scanning is not going to give you the same type of capacity and performance as a tri-band access point like the AP300 that is designed for client propagation. So with all that being said, the exciting part about this is now with the AP300, we have the ability to marry the old installation model with new technology and reduce the amount of cost and the amount of equipment that is used for standard installation. So on the left-hand side, what you're going to see is what we would recommend for an AP300 or a quad, one of our 4 radio quad APs, where you now are installing 6 APs instead of the 26 APs that are on the right. We are able to then use the same cable, the same installation locations, and we've increased the radio density without increasing the AP density. That's the whole idea behind increasing our radios, the number of radios, and why you're seeing multi-band and additional band radios or APs and routers that are coming out. Now, I wanted to take a second and go over the AP300, and one of the complaints that we have had, or one of the pieces of feedback that we've had, is that because our system is designed for a large deployment, like a NFL stadium, for example, it's not the easiest system to install. And so I wanted to take a minute and go over with those of you that take the time to watch this, to show you how easy it is to set up and manage an Everest network utilizing our new AP300, and how you can do it with a simple laptop that you have already in place and an AP300 that you can purchase directly from Microcom. It's actually a very simple process, although it does take a couple of steps. And so I wanted to quickly go through that and just show those steps off to the group. So the first thing is, please visit our website. everestnetworks.com is where you'll find all about Everest Networks, including all of our products, any news announcements that we have, additional information about our company, etc. And of course, most importantly for our purposes, the support tab. So under the support tab, we have a lot of information that will tell you all about our products. When you select the support link, it will ask you to register. That's just so that we are able to understand who is visiting our website. And once there, you can download all of our software as well as our installation guides. You'll see it's a lot of information for you. And for our purposes, what I would suggest is that you download the Everest OS Virtual Controller 2.5. We're looking for the ISO image. The ISO image is actually a disk image, and this is something that you can use to install directly onto a server yourself, or like say onto a laptop. We're going to cover how to install our controller software onto your laptop. While you're there, also, I would recommend that you download the Virtual Controller Installation Guide. The Everest Virtual Controller Installation Guide gives you much more detail than what we're going to go through here, and that's a good guide to have. So again, the idea behind this is to show you a very quick installation that will give you the further details. So the first thing to understand is that our software is free. Our software is, unlike many other vendors that are out there, our software is not something that you pay for or license long-term. We have a virtual console that you can download and put on any device, and it will stay free and allow you to use the Everest access points in perpetuity. In order to run that in order to run our software, the controller software, it does require that you run it in a virtual machine. You can certainly run it on a dedicated server, and we do that all the time. However, to run it on like a laptop, for example, you wouldn't want to overwrite your operating system. So you can download a number of different virtual machine options, including VirtualBox, VMware, or KVM. These are all free options. In our demo today, we're going to use VirtualBox because that's by far one of the most popular. It's free to download. It works on Windows. It works on Mac, et cetera, et cetera. So a very universal package. Once you download and install your controller software, we're going to go through and just give you a quick idea of what it looks like to install using VirtualBox. You download the Everest ISO file, you download and install the virtual machine appliance using VirtualBox here, and you create a new virtual machine. In this case, we're utilizing a completely separate ISO or operating system. So when you start your installation, select Other for the type, and Other Unknown 64-bit for the version. This is a 64-bit software package, so I want to make sure that you have 64-bit. We also recommend that you use at least 2 gig of RAM for your installation, and anywhere from 80 to over 100 gig of hard drive space. And that depends on long-term reporting capacity and how much you want to store long-term. Once you've selected these items in virtual machine, that's it. It actually sets up a virtual machine for you, and then you'll see your virtual machines listed on the left-hand side. You can actually see I have a couple virtual machines listed here: Windows 7, Router OS, and then the one below there is EWC. So you'll see the virtual machine listed, named, in this case, Everest Base Camp, once you have gone through that installation process. It's very simple and very easy to do. The next couple of steps are required to kind of get you to the next step and actually do the installation for the virtual machine. You would select the virtual machine that you've just created from the list on the left-hand side and select Settings, after which you would select Storage, and then you can see down below you would add an optical drive. In this case, what we're doing is virtually plugging in or putting the CD-ROM of our installation software into your virtual CD-ROM. Next, you would choose the virtual optical drive. Once you've created the optical drive, it will show empty. And on the top right-hand side, you can see that you can choose a virtual optical drive. That'll bring up a file browser where you can then take your file browser and point it to the ISO image that you downloaded from the Everest website. Pretty straightforward. And once you select that, you can click OK at the bottom of the screen. And the next step is to set up your network adapter. Again, it's a little bit tough if you have never done it before, so we want to just give you a quick idea as to how easy it is to do. Again, you select the virtual machine and select Settings, and now you select the network option. You select an adapter, and then you put that into bridge mode. We recommend bridge mode because that allows transparency between your laptop and the controller itself, and allow you to have 2 separate IP addresses that you can easily manage. The last step is to select which physical network card you're going to attach to that virtual network. So if you have a laptop, for example, that uses a wired connection, then you would select your wired interface. Otherwise, you'd select your Wi-Fi, for example. Once you've selected OK, and you can then start the virtual machine. Once you start that virtual machine, it'll actually start to go through the installation process. It's self-explanatory. It walks through step by step, and it actually tells you to go grab a cup of coffee because it does take a little while. It takes about 15 minutes. After that is done, you will see the following screen, and you'll know that you've had a successful installation. You'll see TWC login. That means that the controller has successfully successfully installed on your virtual machine. And you will have the ability to log in. The login is, the default login is in the installation manual that we referred to earlier. So you can use that to log in, and then you will see the bottom screen that you see here where you can modify the IP address. And in this case, what you'd want to do is modify the IP address of the controller to be something that you can access either on your local network, or if you just want to do that statically on a closed network, you can do that as well. For example, what you would need to do, though, is have the Basecamp software in the same subnet as your laptop. In this case, we're going to use 192.168.5.100. That's the default IP address of Basecamp. And 192.168.5.1, for example, that would be a static IP address that you could set for your laptop. In the top right, you're going to see the setup that we're trying to put together here is really setting you up the first time as the access point connected to a switch and talking to your laptop and the virtual controller software. So a very simple setup. Now you can plug that AP300 that you've just purchased from Microcom into a network switch. And when you first plug it in, it is going to look for a DHCP server to get an IP address from. If you have a DHCP server on your network, find out what that IP address is, and then you can use PuTTY or any other device to SSH into the access point. If you don't have a DHCP server, like in this sample network here, we don't have a DHCP server. We just want to wait about a minute and a half, and eventually that access point will go into a backup default mode, which will mean that it has an IP address of 192.168.100.240. So in order to SSH into that, you would change your laptop IP address to something in the same subnet, for example, a 192.168.100.241. And then again, use PuTTY or terminal to SSH in, utilizing admin and admin to log in. Once you're entered into the access point and you type help, you will see the screen on the bottom right. And these are all the options that you have with the access point. The step that we're talking about now is really that the access point needs the Basecamp controller software to know its configuration and to have all the features and capabilities that the access point offers you. So at this point then, we use the command line to set the controller IP. Now this controller IP is something that can either be local on your network. For example, if we wanted to do the 192.168.5.100, then we type in, as you can see in bold, set controller IP 192.168.5.100, or this can be cloud-based. The idea behind our software is that you can make your own cloud. You can put it on a internet-based and create your own cloud. So this can be public or private. As long as you have the correct ports forwarded, then our access point will be able to communicate with our software anywhere in the world. Once you've done that, the IP address that you've assigned to your virtual control, you can now log in using a standard browser, and then you'll have the wireless management system at your disposal. The access point is automatically adopted into that wireless management system, and once it's in there, you have a number of options with our wireless management software. Again, our software has been tested by some of the toughest critics in the industry and gives very, very powerful tools as well as reporting capabilities. One of our biggest features that we love about our software, the Basecamp software, is the maps. You know, in a network environment, one of the most important things is to be able to visualize your network, be able to visualize what you have and where your problem issues are. And so instead of an NFL stadium here, imagine an office environment or a hotel that you might be working on, and you have 15 to 20 access points, AP300 spread throughout. You have the ability to easily drag and drop them onto a map, upload your own background image of what that map wants to look like, be able to see the number of access points that you have, be able to see an up-down status of what you have, as well as see roaming heat maps, as well as client heat maps, throughput heat maps, etc. A number of different options available to you. And one of the new features that we've just recently added is client roaming. You can actually select a client, for example, and choose to view them move throughout the network. So you can see them move from one AP to another, and understand the roaming process of your customers and your clients. This is just one of the many features that our Basecamp software offers, including some new features that we're just introducing, like captive portal, for example, as well as cellular offload to help you in some of your more advanced enterprise installations. So that is the end of the presentation. I want to, again, thank you for your time. And I would encourage you to reach out to your Microcom rep and come back to the Microcom website in the next few days and weeks, as the AP300 is shipping soon, and will give you a very economical and highly advanced choice for a tri-band access point that you won't be able to match anywhere in the world. So I encourage you to do what the pros have done and ditch your standard Wi-Fi and upgrade to Everest Wi-Fi today. And with that, I will turn it back over to Julie and answer any questions there might be.
Thank you very much, Ryan. We enjoyed that presentation. And it looks like I do have some questions for you. Let's go ahead and start with the first one here. Let's see what I have. Okay, regarding, obviously, the AP300, First question here is, what is the maximum range to take advantage of the maximum speed?
The maximum range to take advantage of the maximum speed. That is an excellent question, and sadly, a lot of answers in Wi-Fi are the same annoying answer, which is it depends. So it depends on what environment you're installing into. It depends on what kind of interferences you have. If we assume a wide open field with no interferences, which is usually what you see on people's spec sheets, then the maximum, the way that Wi-Fi works is that as you are closer to the access point, the higher modulation you'll have, and so therefore the higher speed you'll have. So if you're within 5 to 10 feet of that access point, then you will be able to get close to 200 to 300 megabits per second, depending on your settings, without any issue. As you go further and further away, that will diminish. But we have these access points deployed in scenarios where we have devices that are 50, 100, 200 feet away and still communicating at decent speeds, 2 by 2, 5 by 5, etc.
Excellent. Thank you, Ryan. Next question here for you. Can any of the radios in tri-band or quad band be set as failover?
Great question. They are not necessarily set as failover, but they are completely independently controlled, and so you can use that as a failover. So the way that we build all of our networks, for example, and the way that we recommend that an Everest network be built, is that the coverage area is overlapped, because you never want to have, as is being pointed out with the question, you never want to have an access point go down or a radio go down and then leave a coverage hole. And so the way that we usually recommend that we design our networks is that in the tri-band, for example, the AP300, you could have independent SSIDs on each one of those radios. So if you have a critical area, then you could set it up so that so each radio has the same SSID. You might have multiple SSIDs on there, but perhaps there's one critical SSID that you need to have on all of them, and then you could set that up, and that way the coverage would not be lost if you lose, again, an access point or a radio.
Thank you very much for that, Ryan. Next question here for you. Is Everest intended for outdoor IP67 rating, or do they need to be covered?
Great question. Excellent question. The AP300 that we've talked about today is designed as an indoor only. It does come with a ceiling or wall mount, so it can easily be desk mounted, wall mounted, or ceiling mounted. But it is not designed to go outdoors. There is a NEMA box that we have a number of customers that have used and have put it outdoors for their own deployments. But the AP300 itself is designed to be an indoor box. However, we do have a number of additional APs beyond the AP300 that are IP67 rated and will give you the full outdoor rating that many are looking for. Still there?